Today we are looking at two types of relationships. There are additive relationships and multiplicative relationships. So the first thing we're looking at is multiplicative relationships. A multiplicative relationship can be described by the equation y equals ax. Remember, when two things are squished up right next to each other like a and x, that means we're going to multiply. So when we multiply, we have a multiplicative relationship. Y represents our output, X represents our input, and A is our multiplier, which is what we are multiplying by. For an additive relationship, we use the equation Y equals X plus A. Y is still our output, X is still our input, but A is now our constant, which means it doesn't change. So the first thing we'll look at here is table 1. Here we see our input, which is X, and our output, which is Y. So I'm trying to figure out how I get from 2 to 8. So I could try a couple of things. I could try multiplying or adding. To get from 2 to 8, I would normally add 6. So I'm going to try that with my next set of values. But 3 plus 6 isn't 12, so I know that I'm not adding. So what I'm going to do is try multiplying. So if I did 4 times 2, that would give me 8. If I did 4 times 3, which is our x, that would give me 12. If I did 4 times 4, which is our x, that would give me 16. If I did 4 times 5, that would give me 20. And if I did 4 times 6, that would give me 24. So this table is showing us a multiplicative relationship. We need to multiply our x times a number to get our y. And that number, our a, our multiplier, is 4 in this case. So our equation would be y equals 4x. Because to get my y, I have to multiply x times 4. Here I'm looking at table 2, and I see that my input, or my x, is starting at 0, and my output, or my y, is starting at 7. So I have to think, can I multiply anything times 0 to get 7? And I know that I can't, so I know that I need to add. So to get from 0 to 7 by adding, I'm doing 0 plus 7. To get my next set, I'm going to do 2 plus the same amount, 7, and that should give me my output, 9. So 2 plus 7 is 9, so that works. Then I have 5 plus 7. That should give me 12, and that works. 9 plus 7 should give me 16, and 10 plus 7 should give me 17. So here our constant, or our a, because this is an additive relationship, is 7. So our equation should be y equals x plus 7. Now there are always 3 ways you can show these kinds of relationships: an equation, a graph, or a table. So let's look at our description of this first one. The cost of an ice cream cone is $1.50. So if I'm looking at my table, my x usually goes on the left and my y usually goes on the right. My input is my independent variable, is my number of cones that I'm buying. And my y is going to be my total cost, because we talked about total cost is normally your dependent variable. So if I buy 0 ice cream cones, I have to think, how much money am I going to spend? If I buy 0 ice cream cones, I'm going to spend $0. If I buy 1 ice cream cone, I'm going to spend $1.50. What about if I buy 2 ice cream cones? That should be $3. If I buy 3 ice cream cones, that would be $4.50. If I buy 4 ice cream cones, that would be $6. And if I buy 5 ice cream cones, that would be $7.50. So now I need to figure out my equation. So I need to think, how do I get from my x value to my y value? Am I adding or multiplying? Here, if I was adding, I could check with 1 and 1.50. To get from 1 to 1.50, I would just be adding 0.50. But if I did that with 2, that would give me 2.50. So I know I'm not adding, I know I have to multiply. Your equation is always going to start with y equals, and then I need to figure out what do I need to multiply by to get my y. So how do I get from 1 to $1.50? I would just multiply by $1.50 because anything times 1 is itself. And then it would be y equals 1.50x would be my whole equation. From here, my last part is my graph. So what's cool about tables is it gives us our ordered pairs. So what you need to do is just think of it as having a parentheses and a comma and an end parentheses. Because if I buy 0 ice cream cones, I'm spending $0. So my first point is going to go right at my origin at 0, 0. And then I'm just going to keep on going with the next point. I'll have a parentheses, a comma, and an end parentheses. And I'm looking at my x-axis, which we remember is our horizontal axis, which means left and right. So I would go to 1 on my horizontal axis, and then on my vertical axis, which is my y-axis, that's my up and down, I'm going to go to 1.50, and my next point is going to go right where those guys meet. And then I'm going to keep doing that for the rest of my ordered pairs. So at 2, 3.00, 3, and 4.50, 4 and 6.00, and then at 5, 7.50. Your last step here is you're going to take a straight edge. Usually I would use my ID, and you're going to draw a straight line through all of those points with an arrow at the end, because that shows that relationship goes on forever and ever for as many ice cream cones as you're going to buy. If you see a graph and it has a point either at the origin or going through the origin, it is going to be a multiplicative relationship. All right, looking at this next one, it says the industrial tech teacher told his class to add 2 inches to the length of each student's project. So the first thing I'm going to look at is my independent and my dependent variable. So my independent variable is going to be the length of my project. So the length of the project. You might have to write kind of small. And then your dependent variable is going to be the total length, because the total length at the end of the project depends on how long the project already was. So for example, if your project was 1 inch, I need to add 2 inches to it, so it's going to be 3 inches. If my project was 2 inches, I need to add 2 inches to it, it would be 4 inches. If my project was 3 inches, it would need to be 5 inches. If my project was 4 inches, I would need to add 2 to be 6 inches. And if my project was already 5 inches, it would need to be 7 inches. We know our equation is going to be our additive relationship because it even says add right in our description. It's always going to start with y equals x, and then plus our constant here is they're adding 2 inches, so it'd be y equals x plus 2. So now we're moving on to graphing again. So because I know my relationship is x plus 2, I know if my project is 0 inches, it needs to be 2 inches. So my first point can just be at 0, 2, which is right here where our x-axis would be 0 and our y-axis would be 2. From there, I would go to my next point, and we're treating it just like ordered pairs, so parentheses 1, comma, 3, parentheses. So then your x-coordinate is 1 and your y-coordinate is 3. But 3 isn't here on my left side, so it would need to be halfway between 2 and 4. My next ordered pair would be 2, 4. Next we have 3, 5, which is halfway between 4 and 6. Then we have 4, 6. So 4 on my x-axis, 6 on my y-axis. And then my last one is 5, 7. So 5 on my x-axis, and then halfway between 6 and 7 on my y-axis. And then your last step is going to be to take that straight edge and draw a line with an arrow right through all those points so we can show that relationship goes on forever and ever. So what you're going to do now is you're going to skip that last one on this paper, put this paper in the notes section of your binder, and get started on your assignment.